The one thing we're going to kind of key on today, and there's maybe two or three little things that's going to spin off this one, is we're just going to work with addition and subtraction. Okay. And to add or subtract matrices, and it's pretty much the same, whether you do addition or subtraction, it still works the exact same thing. You're just going to combine the numbers. Um, you just either add or subtract whatever the signs tell you to do. That you just add or subtract numbers that's in the same location. And we'll show you one here in a minute where we're going to have like matrix A and matrix B, and they're going to tell you just to do A plus B, and we'll do A minus B to show you what it's going to be. The big thing is when you're doing addition and subtraction is one thing you have to have for these is that the matrices, whatever two matrices that you're working with, the matrices must be the same size if you're going to add and subtract. Okay, and when they talk about what a matrix is, what do you do matrix X here for this one? If they talk about matrix X, now you won't quite see this. We're just going to show you this one. We'll actually show you some numbers in a minute. But like the basic setup of this is that they're going to put like X11, then X12, X21, and X22. So they'll, and again, you won't see this other than us just talking about it here. But basically, here's what this means. When they give you these numbers at the bottoms, these are like locations. So if you've got, X to the 3, 4 in this case, looks like X34. The 3 tells you what row it's in, and then the second number tells you what column it's going to be. Okay, and the big thing you've got to remember is when you do something, rows go this way, and columns go this way. Because a lot of times we'll do something, and then it seems, I know it seems like really odd that we have to kind of do that, but sometimes just the way they set up, sometimes it's easy to get those two things confused. So just remember, rows are going to go sideways. So this would be like row 1. You have another way going this way. This would be like row 2. This would be like row 3. Row 4 will be going this way. That you always count. You got to look, see how many go side to side. If we're talking about that one. And your columns, well, that's like columns on the building. Those are kind of easier. Those are going up and down. So, row 1, row 2, row 3, row 4. This will be like column 1, column 2, column 3. If you want one more there, it would be kind of like that. Okay. And when you talk about the size, row is always first, and the columns are always second. I mean, that's the way we'll kind of look at those. All right, now here's where we're actually going to take two matrices we have, and again, it's plural of matrix. They call it matrices for this thing. We're going to give you two matrix A and matrix B. We're going to add them and subtract them just so you can see how it's going to work. And then after that, we'll kind of tweak around, do a couple of different things with those. And whenever they talk about a matrix, they always use a capital letter. If they talk about something on the inside, it's kind of hard to see with the X's back here. But capital letters are always like for the actual matrix. If they do the little letters on the inside, those would be like lowercase letters. Should use something other than X this time, but anyway, it'll be okay. All right, so capital A, here's what it's going to look like. Matrix A is going to be negative 12, 24, negative 3, and 5, and then negative 1, and then 10. Okay, so there's matrix A. And then matrix B, we'll say that it's going to be -3, 1, 2, -4, and then 1, 5. Okay, and what we're going to do, one thing you just, it's good practice on this one, is just being able to practice to know what size it's going to be. So if you're doing matrix A, how many rows and how many columns? So we're going 1, 2, 3 this way. So there's 3 rows, and you've got 1, 2 columns. So they talk about this thing, it's going to be a 3x2 matrix. So it's always the rows first and the columns second. Just like here when we're talking about location, it's rows first, columns second. Same thing if you talk about the size, it's always how many rows you got this way. And you can almost think about this be like you had a bunch of pencils. Think about how many pencils you would need to cover up all the numbers if you laid them side by side. There's 1, there's 2, there's 3. So every how many it takes to cover them up that way, that's your first number. Every how many that you run them this way to cover up all the numbers, that's your second number. So there's, again, 3 rows going this way and then 2 columns going that way. Okay, and then B, same thing, 1, 2, 3 rows, 2 columns there. So it's another 3x2 matrix. Okay, so what we're going to do, we're going to do A plus B first. And with A plus B, it sounds like pretty much what it is. That you're going to take -12 and add it to -3. And then you're going to take 24 and you're going to add it to 1. And then it's -3 plus 2, 5 plus -4. It's -1 plus 1, and then 10 plus 5. Okay, and like a lot of things we've done this year, addition is always really pretty easy because there's not much of it that's going to change. So if you add -12 and -3, it's -15. If you do 24 plus 1, that's just 25. -3 plus 2 is -1. 5 plus -4, same thing as 5 minus 4, that's just 1. -1 plus 1 would make that 0. And then 10 plus 5 is 15. Okay, so there's no tricks. There's no anything you have to be careful of with addition. Addition, you just take the numbers, you add them together, and again, if you start off with a 3x2 matrix, which if you start with 6 numbers here, you've got to finish with 6 numbers here. Okay, subtraction is just as easy, but with subtraction, again, just like every other time we've done subtraction this year, it's one of those you just have to be careful because it's not hard. You just have to be careful when it comes off of being subtraction. Okay, is everybody good with addition first before I cover that up? I'm gonna cover that up just so that we can then see what the subtraction would be. Okay, so A minus B. Okay, and again, the only difference is now it's going to be minus whatever this number is. So it's -12 minus -3. And we'll go back and fix that in a minute because we need to. Then for the next part, it's just 24 minus 1. It's -3 minus 2. It's 5 minus -4. It's -1 minus 1. And then it's 10 minus 5. Okay, again, because of the plus that's here, it's really negative 12 plus 3, which would make that negative 9. 24 minus 1, that's easy, that's just 23. Negative 3 minus 2 would actually be negative 5. You got another minus a negative number here, so it's 5 minus negative 4. That's really 5 plus 4, so that one is 9. Negative 1 minus 1 would be negative 2. And then 10 minus 5 would be 5. Okay, so again, if you're doing subtraction, it's not hard. You just got to remember that when you do that, it's this minus every single number. So again, it's kind of basically that you're going to change all the signs and then you kind of add them or subtract them just depending on what you have there. But just addition, I would say for those, you don't necessarily have to write this down. It's probably one of those you can probably just go ahead and do it straightforward. Subtraction, I would write it down just because if you don't, sometimes it's easy to lose case of the minus negatives. So if you write it this way, then you can kind of see that you got minus negative. You know, you then got to turn around and make that negative 12 plus 3. And then go from there. Okay. And then what we'll do after that is that we'll kind of take the addition and subtraction part. And they use that to then tell you to solve a matrix. Or they may just tell you just to solve. Sometimes they'll say solve for the given matrix. They may say it a bunch of different ways. But basically, it just comes down to this. They'll tell you that if matrix B is 1, 6, negative 1, 2, 6, 1, negative 1, negative 2, 4. All right, and C is going to be 2, 0, 0, negative 1, negative 3, 6, 2, 3, negative 1. And here's where they make you solve for this part. They may tell you to find A when A minus B equals C. Okay, so they give you this little equation, and this is basically, again, with anything like this, we've got subtraction here. It basically winds up you either need to add or subtract these two matrices. So if we're trying to solve for A, we got to get A by itself. So if that's the case, we're just going to add B to both sides. That way that would cancel out. So A really just equals C plus B. So all we've got to do now is just to take these two matrices and then just add them together. Okay, and again, if it's addition, I would say you don't really have to show your work because, again, you're just going to take it one piece at a time as you go through this one. So it's just 1 plus 2, which is 3. It's 6 plus 0, which is 6. And then negative 1 plus 0, which is just negative 1. Okay, it's 2 plus negative 1, which is really just 2 minus 1, so that's 1. It is 6 plus negative 3, which is 6 minus 3, which is 3. And then it's 1 plus 6, which is 7. Okay, and then last row, it's negative 1 plus 2, which is really just 2 minus 1, which is 1. It's negative 2 plus 3, which is 1. And then 4 plus negative 1, which is really 4 minus 1, which would just be 3. Okay, so even if they tell you to solve an equation, it's still the same thing. If it's just adding, subtracting, All you have to do is just figure out, what do I need to add, what I need to subtract. And again, if it's addition, I would say don't worry about showing your work. If it's subtraction, that's where you might want to show your work just to make sure you've got those minus negatives taken care of if you go through that part. Okay. Here's another part where it's not really it's solving, but it's a different kind of solving. Okay, so they're going to ask you to find the unknown values, and it basically looks something like this. Still having some matrix here. We'll have like x plus 3, 2, y minus 1, x plus 1. We'll have like a 9, maybe a z, 2y plus 5, and 7. Okay, so if you got one like this, all that you have to do is basically, if we're just finding out what different values are for this one, all you're going to do is just set each location to each other and then solve it. Okay, and again, if we're saying location, then basically if you're in the top left corner for this one, you set that equal to the top left corner of this one. So you can just take it one piece at a time. So for that one, it's just x plus 3 equals 9. So you can take the two matrices that you have and just break it apart one piece at a time. And from there, you just solve that equation. Well, subtract 3 from both sides, you got x equals 6. All right, you go top right-hand corner. It's 2 here, that's a z here. That one, it's just 2 equal to z. That one, you don't have to do anything because it's already just z equals 2, so you're good there. All right, bottom left-hand corner, you've got y minus 1 and 2y plus 5. And we're just going to set those two things equal. Okay, you got y's on both sides. So in this case, again, that would technically be 1y here. Let's subtract the 1y from both sides. So we got negative 1 would equal y plus 5. And if negative 1 equals y plus 5, again, we're getting y by itself, so let's subtract 5 from both sides. So y would be negative 6. Okay, and you don't have to worry about the last corner here. I mean, you could do that, but you've got x plus 1 equals 7. We already know that x equals 6. So if you've got, even if they put the variable in there a couple of different times, as soon as you solve for it once, it should be the same every single time. So you don't have to keep solving. If they had it in there another time, every time you do this one, x should always equal 6. Somebody was asking about if they would do that where they would, one time make it 6 in one location and one time it's 7 in another location. No, it should be the same answer in the matrix, no matter what you're doing. For any one problem, it should always be the same x, whether it's here or over here or down here. The values all have to be the same for each variable in that part of it there. Okay, so there's pretty much everything straight addition and subtraction. We've got one little bit of multiplication we're going to do today, and then we'll actually dig into it a lot more tomorrow. But the easy multiplication we're going to do, which is what we're doing today, is called scalar multiplication. Okay, and scalar multiplication, here's what basically what it is. And again, this is really pretty easy. So with scalar multiplication, all you're gonna do is they're gonna give you a matrix, matrix A that's here, and then they're gonna tell you, all right, here's matrix A, then tell me what 4A is gonna equal. And this is gonna be really easy because if it's 4 times A, you take every single number in here and you multiply it by 4. So it's gonna be 4, negative 12, 20, and then 0. I know you're thinking, well, they're all going to be that easy. Well, yes and no. So then what they'll do after that is they'll have you kind of mix in some scalar multiplication along with a little bit of addition and subtraction. So you're kind of doing a couple of different parts of it. So they may do something like this. Again, just different problem here. But let's say A is 2, 8, negative 3. And then negative 1, 5, and 2. B will be negative 1, 0, 5, 0, 3, and then negative 2. Okay, and then what they'll do is they'll actually combine a couple of these things together. They're going to tell you then to find 2A minus 3B. So they'll mix it up a little bit of adding and subtracting, along with a little bit of scalar multiplication at the same time. Okay, so let's take it one piece at a time. If the question was, just 2A, let's go ahead and figure out, just double everything in 2A. Don't try to do too much at one time. So just take 2A and double everything. So that's going to be 4, 16, negative 6, negative 2, 10, and then 4. Okay, and before we do the minus part, let's just go ahead and figure out what 3B is. So we're going to take everything in here and go ahead and multiply it by 3. Again, try to take it one little piece at a time. It's negative 3, 0, and then 15. 0, 9, then negative 6. Okay, so once you've got 2A, once you've got 3B, then you can actually go back through and subtract them. And again, with subtraction, that's what I would say, just to kind of be a little bit careful with it. It won't hurt to write it out just to give yourself plenty of room. It's 4 minus negative 3. And again, we'll turn right back around and make that 4 plus 3 in a little bit. It's 16 minus 0, which we're good there. And then negative 6 minus 15. Okay, so we got that. Then it's negative 2 minus 0. It's 10 minus 9. And that's 4 minus negative 6. Okay. And again, all we got to do is just really clean everything up. It's 4 minus negative 3. That's 4 plus 3. So that's 7. 16 minus 0, that's easy. That's 16. Negative 6 minus 15 would be a negative 21. Negative 2, take away nothing, still leaves you with negative 2. 10 minus 9 is 1. And then 4 minus negative 6 is really 4 plus 6. So I get you to 10. Oh, and a good question on this one is, for that final answer we've got here, what's the size of that matrix? How many rows do we have and how many columns do we have? All right. Again, yeah, rows go this way. So we got 2 rows. And we got 1, 2, 3 columns. So that answer would be a 2 by 3 matrix. Okay. Again, it's not a big thing, but it's just one of those to practice with it, that it after a couple of days of it, it'll be easy. So again, rows are going this way, and then columns are going that way. Okay, and then the last thing we got to do, this is where they'll kind of, again, one more time, we'll mix in some scalar multiplication, mix in a little bit of adding, subtracting. Also going to throw in, I guess you can call it division, but it's still kind of multiplying, doing some scalar stuff here. Okay, so then the last thing here. Another solving problem. Okay, so they're going to give you something like this where you've got maybe just it's a solving equation, but it's a solving equation with matrices. So it's 3x minus 2 times this matrix, and that's going to equal that matrix. Okay, and we'll show you how to do it the way it's supposed to be done. Then we'll show you a way if you get stuck sometimes, because sometimes you may just have one of those moments where you just kind of lose it. We'll show you another way you can do this one. It takes a little bit longer, but it gets you the answer for what you want to do. Okay, so let's take away the matrix part for a little bit. Let's just say this was 3x minus 2 equals 17. So if we just blocked everything else out and kind of went back to that first number that was here, something like that. If you've got to solve this thing, if it's 3x minus 2 equals 17, if okay, the first thing we would do is we would add 2 to both sides. Okay, so what we're going to do is eventually we'll do that, but here's the first thing we're going to do before we do that. Oh, sorry, I kind of misspoke on this one. So let's do this. Let's do the scalar multiplication first. Let's do the easy part. We've got 2 times this thing. And again, forget about the 3x and the minus. Let's just do 2 times this thing first. So let's do 2 times everything and make that negative 2, 10, 14, and then 0. So we've got some scalar multiplication right here where we've got 2 times this matrix. Go ahead and do the easy part, multiply that thing times 2. All right, so then we've got the 3x minus this matrix equals that matrix. Okay, now here's where I was going with that. So if it's 3x minus this thing equals 17, if it's minus this thing, everybody okay, we would just add this thing to the other side. If that was 3x minus 14, we would just add 14 to both sides. So this one, you're going to do the same thing. We're just going to add this exact same matrix on this side of the equation. And we're going to add it on this side of the equation. Okay, because again over here, you've got it's a negative 10 and a positive 10. If we took a negative 10 and a positive 10 to get it together, it would be a 0. If we did 0 plus 0, that would be 0. If we did 14 minus 14, again, that's 0. So if we just do the opposite sign with that matrix, it cancels everything out. That'll just leave you with 3x over here. Okay, right-hand side, that's where the work is going to be. It's going to be 17 plus negative 2, which is really 17 minus 2, so that's 15. It's negative 13 plus 10, which is negative 3. It's negative 7 plus 14, or 14 minus 7, which is 7. And then it's 0 plus 0, which is 0. Okay, if this was 3x equals 12, okay, we would just take this part over here and divide it by 3. And if we divide that number by 3, we're going to divide every single one of these things by 3. So then on this part, we get x equals, and then just divide everything by 3. 15 divided by 3 is 5. Negative 3 divided by 3 is negative 1. That stays a fraction. 7/3, not much you can do with that one, so just leave it that way. And then 0 divided by 3 is still just 0. Yeah. Right there. Okay, so again, just doing some scalar multiplication, just double everything. Again, forget about the minus. Just go ahead and double everything. Get it to here. That's minus that one, so we'll do just like a normal solving equation. If it's minus this thing, we'll add that same thing to both sides. And then once you get to here, if it's 3x, you got to divide by 3 to get the x by itself. So if we divide by 3 here, divide by 3 here, and then whatever you get when you divide everything by 3, that's the final answer that we're looking for there. Bless you. Okay, and then and this is not just an example, just something that if they throw this out here, that you may see them talk about this one a little bit here and there, but a matrix with all zeros. Anybody want to take a guess what they might call that? Yeah, weird enough. Matrix with all zero is called a zero matrix because it's just got a bunch of nothing in it. Now, sometimes on that one, if it's all zeros in the matrix, we'll go an AKA here because sometimes they also call that, or also known as, the identity matrix of addition. So if they happen to, because sometimes they'll sneak that in, and you're like, "What was it?" Somebody. So if it's something with all zeros, it's a zero matrix. And again, it can be any size. It can be like a 2x2, or a 3x3, or a 2x3, or a 5x4. Size of it doesn't matter. If it's all zeros, they just call it the zero matrix or the identity matrix of addition. Whatever you call it, it's just got a bunch of zeros in it.